Welcome to The Explainer, where today we're going to look at how biology is literally being engineered to build our future. And it all starts with a problem you would never ever expect.
All right, so picture this, massive piles of waste flowers in India. An R&D team is looking at them, and they spot something weird. A tough, leathery film is just growing on top of the old petals. What in the world is going on here?
That one little observation, well, it sparked an absolutely incredible idea. One that could turn a huge waste problem into high fashion. So get this. A startup called Fool.co looked at the 8 metric tons of flowers being thrown into the River Ganga every single day. And they didn't see trash. No, they saw a raw material. They realized they could use that weird biological process to make something amazing. And of course, they gave it a brilliant name. They called it Fleather. You know, flower plus leather. It's catchy, right? Perfectly describes what it is. Okay, but how does it actually work? This is where it gets super cool. You know how regular animal leather gets its strength from a protein called collagen? Well, Fleather gets its strength from something called chitin. It's basically the same kind of structural stuff, but it's made by the tiny microbes munching on the flower waste. It's a perfect swap out, all from nature. So, you have to ask yourself, right? Is this just a one-off, super clever trick from one company? Or is this a clue that something much, much bigger is happening? Turns out it's definitely part of something bigger. It's called the bioeconomy. And this idea is the key to everything we're talking about today. So what is the bioeconomy? Put simply, it's using life itself. We're talking everything from microbes to plants as the actual factory for new industries and products. It's all about using nature's own processes to build our world, but in a way that actually lasts. And listen, this isn't some fringe science idea. Governments are all in. The US, for instance, has a whole national blueprint for this. They're trying to fast-track these ideas from the lab to the marketplace and even train up a whole new workforce to make it happen. Okay, so from a single startup, let's zoom way out. Let's see what the bioeconomy looks like on a massive, citywide scale. And trust me, you are not going to believe this one. I mean, look at this. This is Bakke in Copenhagen. It's a power plant that turns waste into energy, and it has a ski slope on the roof. I'm not kidding. You can literally ski down the side of a power plant that's burning the city's garbage. And the scale here is just mind-blowing. This one plant burns through 600,000 tons of city trash every single year. But burning all that trash is just the beginning. The real magic, the absolute genius of this place, is what they're planning to do with their emissions. They're about to completely change the game. Okay, just look at these numbers. It's a total game changer. Without the special tack, yeah, the plant pollutes. But with it, this thing called carbon capture, it not only cuts way down on fossil fuel emissions, it actually grabs the carbon from all the organic stuff like food and paper and stores it. So the plant goes from being a polluter to being a carbon negative. It's literally pulling CO2 out of the air. And get this, it does all that without losing any energy efficiency. Incredible. All right, we've gone from flowers to a giant power plant. Now, we're going to zoom in way in. We're talking about an entire biological kingdom that could be the next frontier of innovation. Fungi. So, you've got these tiny little spores. They start to grow, sending out these little threads. And those threads just keep branching and branching until they form this huge, interconnected, root-like web called mycelium. Think of it as nature's ultimate construction crew. It breaks stuff down and builds new stuff up. And this is the mind-blowing part. That mycelium network, it's not just one thing. It's a platform. It's like nature's own programmable 3D printer. You can basically tell it what to build. Seriously, you feed it different kinds of agricultural waste, like leftover sawdust or corn husks, and you can grow almost anything. You want vegan leather? Done. New textiles? Easy. Packaging material to replace plastic foam? You got it. Construction materials? Yep. Even alternatives to meat. It's an entire manufacturing system that's totally sustainable. Okay, so let's tie all of this together. What does this actually mean for us, for the future of our planet? Think about what we've seen. Flowers nobody wanted, now they're leather. A city's trash, now it's clean energy that actually helps the climate. And fungi, they can turn our farm leftovers into, well, just about anything. In every case, we're closing the loop. We're turning waste into something valuable. And this is what it's all about. This isn't just about cool science projects.
The real goal here is to build a whole new system, one that helps with food security, saves our natural resources, grows the economy, and just generally makes life better for everyone. It's a complete vision for a future that actually works.
So it all comes down to this one final, powerful question. Every single thing we talked about started with someone looking at waste and seeing potential. So, what if our biggest problems, our biggest streams of trash, aren't problems at all? What if they're actually our greatest untapped resources?